Hey everybody, thanks for clicking on this video. Today we're going to be looking at converting rectangular coordinates into polar coordinates. If you want to follow along, the links to the companion worksheet are in the description below. Also, don't forget to click that subscribe button so you can stay up to date on all the videos that we have coming out from this channel. So let's get started. So what we're given a point in rectangular or Cartesian. And so we want to convert it into polar. Well, first let's see where this thing is located. So this is at 1, -1. So that's over here in the fourth quadrant. 1, -1. Now one way I often tell people to think about this is draw a right triangle, because the x and y coordinates are like two sides of a right triangle. This side is 1 and this side is -1 because it's down below. So the question is, what is the hypotenuse? Well, 1 squared plus -1 squared equals c squared. So that's 1 plus 1 equals c squared. So 2 equals c squared. So radical 2 equals c. So that means that is our distance from the origin. Now what is this angle? Well, if we think about it, this is a special right triangle because the two sides are the same. So this is 45 degrees. Now, all the angles that we talk about are always measured from the positive x-axis. So what we're concerned with is, what is this angle? Well, it's 45 degrees away from making a full turn. So we take 360 degrees and subtract 45 degrees. And so this angle is 315 degrees. Well, what we found is the key information to put this into polar, because polar wants to know how far away is it from the origin. We know that. That's the hypotenuse. That's square root of 2. And what's the angle? The angle is 315 degrees. So there's our point. And now it's in polar. So let's look at this second one. Here we've got the point 3, 0. So where's that? Well, actually that is on the x-axis. Right here, 3, 0. Now, a problem like this is often going to weird people out because you can't do it like we did this one because there's no right triangle. But actually, this actually is easier because how far away is it from the origin? It's 3. And what's the angle? How much do you have to rotate to pass through this point? Well, you don't. So the point is 3, 0 in polar, as it is 3, 0 in Cartesian. The thing to remember is these two don't mean the same as this. This means we move 3 units to the left and 0 units up. This means we're 3 units away from the origin, but rotated 0 degrees. That's the difference. So for our third one, we are in the first quadrant because we go over 1 and up radical 3. So 1, radical 3. So that means that we can draw a right triangle here. And so we have 1, we have radical 3. Now if we remember our special right triangles, this is going to be a 2 here. And this is 60 degrees, and this is 30 degrees. This is a 30, 60, 90 right triangle. So therefore, our distance in polar from the origin in a straight line is 2. And the angle, the amount we had to rotate, was 60 degrees. And there's our point in polar. So for number 4, we have these coordinates, negative radical 2 over 2, negative radical 2 over 2. That's in the third quadrant. Negative radical 2 over 2, negative radical 2 over 2. So if I draw my triangle, we've got negative radical 2 over 2, negative radical 2 over 2. So using the Pythagorean theorem, we take negative radical 2 over 2, square that, plus negative radical 2 over 2, square that, and that gives us c squared. And we square both of these, we get 1/2 half. So that means c squared is equal to 1. So that means c equals 1. And our c is always going to be a positive. X and y can be plus or minus because it's either to the left or right or up or down from the origin. But the distance is never negative, at least not for what we're going to be working with. Now, if you notice, this is a right triangle, and the two sides are equal. So that means this is a 45, 45, 90 triangle. So the angle we're interested in is, well, it's 45 degrees more than 180. So we take 180 and add 45 degrees to it, and we get 225 degrees. So that means our point in polar is 1, 225 degrees. For number 5, we have this point, negative 2.3, 0.4. So that's going to be over here, negative 2.3, 0.4. So if I draw out my right triangle, I get negative 2.3, 0.4. Now this is definitely not a special right triangle, so I'm going to have to compute the hypotenuse here. So negative 2.3 squared plus 0.4 squared equals c squared. So using my calculator, I take quantity, negative 2.3 squared, and I get 5.29. 0.4 squared is 0.16 equals c squared. So if I add 0.16, I get 5.45 equals c squared. So if I take the square root of that, I get 2.335 for c. So that's the length of our hypotenuse, 2.335. Now, in this triangle, we need to figure out this length here. We don't know what that angle is. And I'm just going to call that theta. And so we know that tangent of theta, whatever it is this ratio, 0.4 over 2.3. Now, I'm ignoring the negative for right now, because as far as we're concerned, the x and y axes don't exist. We're just looking at the right triangle right now. So to get theta, I need to take arctan of that ratio, 0.4 over 2.3. So arctan of 0.4 over 2.3. And we get 9.866 degrees. That's theta. But what we want is this right here. So that's going to be 180 minus 9.866 degrees. So if I take 180 and minus that, we get 170.134 degrees. And so that is our angle from here to here. So in polar, we have 2.335, that's our distance, and our angle is 170.134 degrees. All right. Now for the last one, here we just have x and y. We don't know anything else. And so what this is sort of abstracting, how do we find this in all situations? Well, what we do is we say, well, how did we find the distance? We plug in the two sides we know into the Pythagorean theorem. But we don't know what x and y is, so we just put x squared and y squared. Well, if we want c by itself, we have to take the square root. So square root of x squared plus y squared is c. That is our hypotenuse. That is our distance. Now, how do we find the angle? Well, how did we find the angle up in number 5? We set up the tangent ratio. We do the same thing here. Tangent of theta, whatever this angle is y over x. So that means theta is arctan of y over x. And so what we have right here is we have a generalized form of how to find any point how to turn it from rectangular into polar. What we do to find the distance is we take the square root of x squared plus y squared, comma. To find the angle, we take arctan of the y value divided by the x value. And so if you look back through the video, you can apply this in all those cases, even in cases where we didn't know those special right triangles. Thanks for watching. If you liked the video, please give it a thumbs up. For more videos like this, click the subscribe button. If you have suggestions or problems you want to see worked out, type a comment below. To support the channel, click the Patreon link to help keep this going. Thanks so much for watching, and remember, the best way to understand something is to do it.